We experience sound in our everyday lives, but sometimes it's not loud enough. One way we've learned to fix that problem is by using a microphone and speaker to amplify the sound. Someone speaks, which creates sound waves. Those sound waves hit the microphone and are sent to the speaker, which amplifies the sound. Finally, the amplified sound waves travel through the air to the ears of those who are listening. But how does this all work in detail? To start off, the initial sound, which would be the voice, creates the sound wave. The person's diaphragm pushes air from the lungs to the vocal cords in the throat. This causes vibrations which produce sound. The vibrations from each sound wave travel through the air as a longitudinal wave. In a longitudinal wave, the particles that are displaced in the medium by the vibrations move in a parallel line, continuing as a ripple effect. The typical frequency of a voice would be between 200 and 2500 Hz. The typical amplitude of a voice would be 60 dB, which is not very loud. In order to increase the loudness or amplitude of the sound from the voice, we need a microphone and stereo system. First, the sound waves from the voice with a low amplitude hits the diaphragm of the microphone, causing it to vibrate. The sound waves vibrating the diaphragm have compressions and rarefactions that are not very dense. As the diaphragm vibrates, the coil attached to it vibrates as well. This coil is attached to a permanent magnet that has produced a magnetic field. As the coil vibrates through that magnetic field, an electrical current is produced, and the sound wave travels through the wire as an electrical current. As the electrical energy flows from the microphone to the speaker, the sound in the form of electrons flows out of the wire and through the coil, making the coil wire an electromagnet. The south and the north poles of the magnet reverse as electric current flows clockwise and counterclockwise. The coil moves toward and away from the magnet depending on electricity flow, and since the speaker is connected to the coil, it too moves back and forth. The bottom of the speaker will push air back and forth, recreating those sound waves to travel through the air at a higher amplitude. Compressions are tightly compacted and rarefactions have few air particles, indicating the particles are being pushed out harder, which increases amplitude. Because amplitude has increased, the particles have become tightly compacted, meaning they're more dense. The adjusted frequency for a speaker would be around 35 to 20,000 Hz. The typical amplitude of a speaker is 85 dB, which is pretty loud. The sound of the voice is now able to reach a large amount of people at a good volume or amplitude. We use microphones and speakers consistently throughout our social communities. We use it during interactions between groups of people involving issues such as warfare, safety, rights, justice, or class. Some of the benefits of using a microphone and speaker in society are authority, being able to get a hold of a large amount of people at once, weather and safety warnings, being able to reach people at large, demonstrations can be made loud to get an idea across, or it could also be used for entertainment purposes. But there are also limitations to being able to use such loud equipment. If used at too high of a volume, the speaker could cause potential hearing damage or even hearing loss. But overall, socially, a microphone and speaker are very beneficial to society. The use of a microphone and speaker is a good solution to bringing awareness to the community for use of communication, safety, or even justice. As long as people use these devices wisely, they are more beneficial to society than they are harmful. Microphones and speakers do the trick.